I made a video a while ago about Appendix F and how good it is for calculating current carrying capacities of cables. I wanted to update it a bit, and I've had my pens out to help me, so they're the highlight of my day. So Appendix F is really great for calculating current carrying capacities of cables, especially at level 2. You might find it a little bit limited for level 3, but it's still very useful. The front page I love because it's what I like to call an idiot's guide. It helped me out when I was learning to calculate cable carrying capacities, so I think it's really good. You've got the procedure there where first of all you need to find your design current, which is IB. Then you need to select a suitable size of protective device, so that's IN. Okay, then it gives you this little formula that IN has to be equal to or greater than IB. And then you've got your formula for calculating your current carrying capacity, taking into account the different correction factors that you have, which I've highlighted here. So it looks complicated, but it's actually quite simple, and the best bit is that the factors are all shown down here, so you've got CA and so on, and it even tells you which page to find them on or which table to look at. So it's really good like that. So that's your idiot's guide to refer to if you're just getting used to the tables, because they can be a little bit confusing. So flipping over, we've got our basic voltage drop and the voltage drop calculation as well. There's also the information on the maximum permissible voltage drops for lighting circuits and all other circuits, so make sure you're not getting those mixed up. Then if we're looking at the ambient temperature surrounding the cable, so that might be the temperature in the room, then we've got table F1, which is for ambient temperature. Important thing to note here is there's a differentiation between thermoplastic and thermosetting cables as well, so they're quite useful. Again, this is quite limited compared with the main regs book. It only goes up to a certain amount of degrees. If you've got higher than those degrees, you'd need to refer to BS 7671. Next thing you need to consider when you're selecting your cables is thermal insulation, and that would be thermal insulation in a building, like loft insulation or insulation that you find in stud walls. So that's table F2. Okay, one of the most important things to take into account here is that if you've got over 500 mil, so half a meter of insulation, then the rating factor remains the same at 0.5. So that's a good one to try and remember if you know that you've got more than 500 mil of insulation. But otherwise you've got the other ones there, even for just short runs of cable under insulation or touching insulation. It will affect the amount of current that your cable can carry. So it's a really important one to take into account. Finally, for the calculation for IT, we've got our grouping factor, and grouping factor here is table F3, and it's looking at cables that are bunched together or in there, etc. And then you've got the number of circuits. One thing that's really important to remember here is that you're taking into account other circuits plus the circuit that you're installing. So don't make the mistake of thinking that if there's one other circuit, you're only looking at one. You'd be needing to look at two to take into account both of those circuits. The next tricky bit, tables F4 to F6. Okay, few important things to remember here is that although most of the current carrying capacities and voltage drops won't be that different, it can still lead to mistakes, so you need to be careful of that. So table F41 is for single core cables, so that's cables that we might install in trunking or conduit. And what we're looking at here is our current carrying capacity of the cable dependent on the installation method, and then once we found that, comparing it with the accurate size of cable. It's really important that you're choosing a current carrying capacity greater than the one that you've calculated, so that you know that your cable can easily handle it. One update that there's been is this section over here, which is talking about cables that are separated by more than their one diameter or so. So that's a bit different in there. Chances are most of the time you won't be using that, because you're more likely to be using cable tray for armoured cables, and this doesn't cover that. So F41 is to calculate your size of cable based on the current that it can carry, and it's for single cables. Table F42 again is for single cables, and what we're looking at here is our voltage drop. So you've got different voltage drops. So once you know the size of your cable, say for example 1.5, then we can look at the installation methods. So let's say click direct, and then we go down to here, and that will give our millivolt amps per meter for volt drop, which you can use in your volt drop calculation. So those F41 and F42 are for single cables. F51 is for multi-core cables, so that might be like 3-core cables or so. You treat it in exactly the same way. Once you've calculated the current carrying capacity, the IT, then you can find the current carrying capacity of the cable, and once you've found current carrying capacity that's equal to or greater than the one that you calculated, you can then find the cross-sectional area of the cable. So that's table F51 for multi-core cables, and that's generally round cables. Next up, we've got table F52, okay, and that's to find the voltage drop for multi-core cables. Okay, so it's quite a simple table to use. You just look at the size of cable you've got, check out whether it's 2-core or so on and so forth, and then you find your millivolt amps per meter. So that's quite easy to use as well, and that's the one where you'd use in your calculation for voltage drop. Finally, the easiest table of all to use is table F6, and this is for flat profile cables, so what you call twin and earth. Okay, so it's for those ones, just flat profile twin and earth cables. And the great thing about this is your current carrying capacities, your cable size, and your voltage drop are all on one page, so it makes it much easier to use. So if you know the size of your cable, you still have to calculate it using the IT calculation that I talked about at the beginning, but now what we're looking at is the millivolt amps per meter, and then you go straight along to the end and you've got your volt drop that you can use in your volt drop calculation. This is a bit longer than previous videos I've made. I hate making them too long because I think they get boring. I know I get bored with them and lose interest, but I hope you found this really helpful.